Forget about those cute little electric air taxis. With the new development of high vertical takeoff and landing aircraft, the US Air Force intends to push things to the next level. You've probably heard about electric vehicle takeoff and landing, or eVTOL, planes which are being developed to power a future fleet of flying taxis. A new form of VTOL aircraft has emerged, the high-speed VTOL, or HSVTOL. An early iteration comes from Bell, a pioneer in aviation in the United States, which recently presented a new collection of designs displaying the technology. So in today's video, we'll take a deep dive into high-speed VTOL, also known as HSVTOL. Bell is one of the first to take the technology from legendary V-22 Osprey it manufactured for the US military and combine it with ideas it has floated for eVTOL air taxi usage. The fundamental difference between eVTOL and HSVTOL is that after vertical takeoff, the latter employs turbofans to achieve speeds and ranges comparable to fighter aircraft, whilst the former is currently restricted in range because of the battery technology it depends on. Bell's concept planes range in size from 4,000 pounds all the way up to 100,000 pounds, and they're all meant to fly by themselves. Bell says that their HSVTOL aircraft can achieve speeds of 460 miles per hour or 740 kilometers per hour, though no particular range data has been released yet. The V-22 Osprey had a cruising speed and range double that of the helicopters it replaced, according to the company. The aircraft will also deliver improved runway independence, aircraft survivability, mission flexibility, and performance over legacy platforms, according to the Aviation Bell. According to the documents, the convergence of tilt-rotor aircraft capabilities, digital flight control improvements, and upcoming propulsion technologies will develop HSVTOL technology for current military operations to assist the next generation of warfighters. About the HSVTOL. The HSVTOL system will combine a helicopter's hover capabilities with a jet speed, range, and survivability. The plane will have jet-like speeds of over 400 knots and the scalability to support a variety of tasks, including reconnaissance, autonomous ISR strike, and tactical mobility. The AFW Works HSVTOL Concept Challenge, a crowdsourcing endeavor for the US Air Force and US Special Operations Command, includes Bell as one of the 11 companies participating. Market research funds are provided to companies in order to advance solutions that allow for maximum adaptability under difficult conditions, a tremendous leap forward in rotorcraft capability. Bell is working on the concepts as part of an Air Force program to encourage military-related innovation. Following a request for high-speed VTOL suggestions last spring, Air Force officials recently chose 35 finalists for further investigation with funds to further develop those concepts. Among these was Bell's HSVTOL. Still, there's a long way to go between where the design is today and the finished product. This entails perfecting a number of technologies that are now inactive. Nonetheless, the ideas are intriguing to consider. Bell's HSVTOL technology represents a step-change enhancement in rotorcraft capabilities, stated Jason Hurst, Vice President of Bell's Innovation Division. By using knowledge from a strong past of technological discovery and tight cooperation with the Department of Defense and research laboratories, our technology investments have minimized risk and equipped us for quick development of HSVTOL in a digital engineering environment, Hurst stated. Bell claims to have a great track record in aviation technology development, implying that it will be able to create these high-speed planes quickly. It's worth emphasizing that HSVTOL aircraft are still in the idea stage, and their development represents a significant technological leap forward from flying taxis, which have yet to fly. Before Bell's idea became a reality, we'll have to see if companies like Volocopter, a flying taxi startup, can maintain their promise of offering commercial services by 2024. Updates. A successful demonstration of folding rotor technology and computerized flight control systems was just completed by the business. Bell's high-speed vertical takeoff and landing, or HSVTOL ideas, reached a major development milestone in December with a full-scale demonstration of its folding rotor technology and digital flight control systems. Bell's HSVTOL technology advanced to a technology readiness level 4 in 2021, and our 2022 development plan has us rapidly progressing to TRL 5 with an integrated demonstration. one step closer to flight, said Jeff Nissen, Senior Manager of Advanced Technology and the eVTOL Program Manager at Bell. Bell's test confirmed numerous key enabling technologies for eVTOL, including dependable folding rotor hardware and stable digital flight control. The team finished the system's digital design in record time and quickly constructed and tested the hardware and software necessary to convert the rotor system from turboprop to jet mode. Seeing our digital design come to life in this full-scale presentation was a thrilling experience, and it allowed us to quickly confirm important assumptions we were making about the system's operation. We're excited to combine these findings as we prepare to develop an integrated demo incorporating more aircraft systems. Troy Shank, Manager, eVTOL Lead Engineer at Bell. Bell has a long history of developing cutting-edge VTOL systems that advance aviation. The V-280 Valor long-range attack aircraft prototype just completed a 3-year flying test with over 200 hours of flight time, demonstrating that it possesses the revolutionary speed, range, and agility required to modernize U.S. military aviation. Bell used digital design, sophisticated manufacturing technology, and emerging commercial processes to improve dependability, operational efficiency, affordability, and digital accuracy for its products. The Bell V-280 Valor program has demonstrated its worth through a quick development cycle and through a flight testing program. What if we told you this wasn't the only technology that Bell displayed? They did, however, present 35 high-speed VTOL aircraft ideas within the same time period. We'd probably be here for a whole day if we went through the whole thing. Let's take a look at some honorable mentions. VTOL aircraft systems with adaptive fluidic propulsion were developed by Jetoptera and Northrop Grumman. Fast-spinning propellers or ducted fans located outside the aircraft's fuselage, pushing air to produce thrust in whichever direction they're pointing, are something practically all air taxi designs have in common. However, not this one from Seattle. Jetoptera's J2000 concept is an unusual take on the VTOL intercity aircraft. Employing the company's own proprietary propulsion technology, Jetoptera's fluid propulsion systems are similar to Dyson's bladeless fans in that they don't have spinning blades. They are, of course, splitting blades elsewhere in the system, just as there are in the Dyson. Jetoptera is unconcerned with where it obtains the compressed air, but it believes that battery technology will need to achieve energy density values of roughly 1,500 watt-hours per kilogram. Current state-of-the-art batteries are around 260 watt-hours per kilogram, before an electric compressor can be fitted on the J2000. In the meantime, it's testing bigger propulsion systems using gas generators, including a 75 kilowatt-hour turboshaft system based on the Accutronic SP75. The Jet Quad Fusion Flight. In a similar spirit, the Jet Quad is a quad-turbine VTOL drone that self-balances on thrust vectoring nozzles that respond quickly. This quadcopter on overdrive is a smaller version of the Speeder, resembling a larger suitcase rather than a full-size pallet, and weighs only 50 pounds. This concept is likely to scale nicely. The latest prototype incorporates 4 diesel-powered microturbine jet engines that deliver a combined 200 horsepower at maximum throttle, rather than the customary 4 electric motors and propellers. The force from these engines may be directed vertically during takeoff and landing, or horizontally while in flight, thanks to a patented vectoring technology known as the H configuration. The aircraft's production version is expected to reach over 300 miles per hour with a single fill on its 5-gallon fuel tank, providing 30 minutes of hovering or 15 minutes of cruising. The installation of afterburners, for example, might significantly increase its speed in the future. Advanced Tactics Rotor X, the Barracuda. This is yet another behemoth. In VTOL mode, where it practically appears like a 14-seat airplane with a big quadcopter system built in, the Barracuda is the most similar design to the current wave of eVTOL air taxis. It isn't electric. Its rotors are powered by 4 independent turboprop engines, with variable blade pitch control apparently used to balance the aircraft in hover. When the aircraft is in cruise mode, the front propellers tilt lower and the rear prop rises, each on long pylons, allowing both banks of massive rotors to access clean airflow and contribute to forward force. Vox Aircraft, Unmanned Aerial Vehicle. The Vox UAV A lift and cruise design with 4 multi-copter-like rotors for lift and pusher prop for the cruise appears to be another electrically driven VTOL aircraft with a range-extending onboard generator. The lift rotors are encased in wing strakes to reduce the chance of rotor impact. The manufacturer claims that its UAV, which starts at 400 pounds, can outperform a similar-sized rotocraft like the MQ-8B Fire Scout. It will give you 4 times the effective range on the same fuel load, twice the cargo, a far higher service ceiling, and most importantly in this context, 3 times the speed with a maximum cruising speed of 300 knots. So how do you feel about the HS VTOL and the other innovations mentioned in the video? Although the majority of them are concepts, they do not appear to be far off in the future. But do you think they will ever be realized? Let us know what you think in the comment section down below.